When working in the AWS Cloud, one of the most important operational decisions you'll make is whether a task should be handled as a one-time operation or as a repeatable, automated process. This choice directly impacts reliability, security, cost, and long-term scalability. Let's break this down in a practical way. First, let's talk about one-time operations. One-time operations are typically manual tasks performed through the AWS Management Console or a quick AWS CLI command. These are best suited for infrequent, low-risk activities where building automation would add unnecessary overhead. For example, launching a temporary EC2 instance to test an idea, manually checking a CloudWatch metric during troubleshooting, making a small configuration change after an audit finding. These tasks are fast to execute and require little setup, but they come with higher risk of human error and are hard to reproduce consistently. That's why AWS generally discourages using one-time operations for production-critical workloads. Now let's contrast that with repeatable processes. Repeatable processes are automated, standardized, and version-controlled. They use tools like infrastructure as code, AWS CloudFormation or Terraform, scripts with the AWS CLI or SDKs, C/CD pipelines, AWS Systems Manager automation. These processes are ideal for recurring or high-impact tasks, especially in production environments. For example, deploying the same infrastructure to development, staging, and production, automatically patching hundreds of EC2 instances every month, running scheduled backups or disaster recovery workflows. Repeatable processes take more time to set up initially, but they dramatically reduce risk, improve consistency, and support compliance in auditing. So how do you decide which approach to use? You evaluate a few key factors. Frequency. If the task happens once or very rarely, a one-time operation may be fine. If it happens regularly, automation is the better choice. Environment. Temporary labs or sandboxes often allow manual actions. Production and staging environments strongly favor repeatable processes. Impact of failure. If a mistake would cause downtime, data loss, or security exposure, automation is the safer option. Complexity. Simple, single-step tasks can be manual. Multi-step workflows should be automated. Compliance and auditing. If you need traceability, approvals, or repeatable evidence, automated processes are required. Scalability. Managing a handful of resources manually may work. Managing dozens or hundreds does not. Let's look at a few real examples. Launching a single EC2 instance for a 2-hour test? That's a one-time operation. The console is perfectly fine. Deploying identical environments across multiple regions? That's a repeatable process. Infrastructure as code is the correct choice. Manually restoring a single file from an S3 bucket? One-time operation. Automating backups for an entire application stack? Repeatable process using AWS Backup. The key takeaway, and this is important for the exam, is that AWS best practices strongly favor repeatable, automated processes for production, compliance-heavy, or large-scale environments. One-time operations are acceptable for temporary, low-impact, or exploratory tasks. As organizations mature in the cloud, they naturally move away from manual actions and toward automation. This shift is a core principle of operational excellence in AWS and a recurring theme throughout the Cloud Practitioner exam. Before we compare deployment models, it's important to understand what AWS means by a cloud deployment. In a cloud deployment, all of your applications and infrastructure run entirely in the public cloud, using AWS managed data centers. That means AWS owns and operates the physical buildings, servers, storage, networking, and power, while you focus on what runs on top of that infrastructure. This model follows the AWS shared responsibility model. AWS is responsible for the security of the cloud, things like physical data centers, hardware, and the underlying infrastructure. Customers are responsible for security in the cloud, their data, applications, operating systems, configurations, and access controls. From a financial perspective, cloud deployments use an operational expense model, or OpEx. Instead of buying servers upfront, you pay only for what you use. This removes large capital investments and makes costs much more flexible and predictable. One of the biggest advantages of the public cloud is scalability. Resources can scale up or down almost instantly. If your application suddenly needs more capacity, AWS can provide it in minutes instead of weeks or months. Because there's no physical infrastructure to maintain, teams can focus on innovation instead of maintenance. There's no need to worry about hardware failures, data center space, or capacity planning at the physical level. In AWS, this is the default deployment model. Services like Amazon EC2, Amazon S3, Amazon RDS, and AWS Lambda all run on AWS's globally distributed public cloud infrastructure. For the exam, remember this. A cloud deployment is best suited for startups, modern web applications, analytics workloads, disaster recovery scenarios, and any organization that wants agility, scalability, and cost efficiency without managing physical hardware. Now let's talk about on-premises deployment, which is often referred to as a private cloud. In this model, the organization owns and operates its own infrastructure. That means the servers, storage, networking equipment, and data centers are all located in facilities that the company controls directly, either in their own buildings or in a dedicated colocation space. One of the biggest characteristics of an on-premises environment is full control. The organization decides exactly how systems are designed, secured, and operated. This level of control is often required for highly sensitive workloads, strict regulatory environments, or situations where data must stay within a specific geographic location. However, this control comes with trade-offs. From a cost perspective, on-premises environments rely heavily on capital expenditure, or CapEx. Organizations must purchase hardware upfront, plan for peak capacity, and invest in long-term infrastructure, even if it's not fully utilized all the time. In addition, they must budget for data center space, power, cooling, networking, and physical security. There is also a significant operational responsibility. The organization is fully responsible for patching operating systems, maintaining hardware, managing networking and firewalls, ensuring power, cooling, and physical security, handling hardware failures and disaster recovery. This means larger IT teams and higher ongoing operational effort compared to cloud environments. From a security and compliance standpoint, on-premises deployments can be a good fit when organizations need custom security controls, strict compliance requirements, or full data locality. That's why this model is still common in industries like finance, healthcare, government, and defense. Now, in the AWS context, even though AWS is a public cloud provider, it recognizes that many organizations still run on-premises systems. That's why AWS supports hybrid connectivity. Services like AWS Direct Connect allow companies to create private, dedicated network connections between their on-premises data centers and AWS, enabling smoother integration and migration paths. So to summarize for the exam, On-premises deployment means the organization owns and manages everything. It offers maximum control and compliance, but at higher cost and operational effort. AWS supports on-premises environments through hybrid and connectivity services, not by hosting customer-owned private clouds directly. When you see exam questions mentioning full control, CapEx, data sovereignty, or strict regulatory requirements, think on-premises or private cloud. A hybrid deployment model combines on-premises infrastructure with public cloud resources, usually AWS. Instead of choosing only cloud or only on-premises, organizations use both together as a single, connected environment. The key idea of hybrid is flexibility. Some workloads run on-premises because of compliance, latency, or legacy requirements, while other workloads take advantage of AWS for scalability, analytics, or innovation. You place each workload where it makes the most sense. To make hybrid work, interoperability is critical. AWS provides secure, reliable connectivity so systems in your data center can communicate with AWS resources as if they were part of the same network. This is commonly achieved using services like AWS Direct Connect, which provides private, low-latency network connections between on-premises environments and AWS. One common hybrid use case is cloud bursting. For example, an organization might normally run workloads on premises, but during peak demand, such as seasonal traffic spikes, it can temporarily scale into AWS to handle extra load. This avoids overbuying hardware that sits idle most of the year. Hybrid deployments are also widely used for business continuity and disaster recovery. Instead of building a second physical data center, organizations can use AWS as an off-site backup or recovery environment. If the on-premises system fails, workloads can be restored or continued in the cloud. AWS offers several services specifically designed for hybrid architectures. AWS Outposts brings AWS hardware and services directly into your own data center, allowing you to run AWS services locally with the same APIs and tools. AWS Storage Gateway connects on-premises storage systems with AWS Cloud Storage, enabling seamless backups and data tiering. AWS Direct Connect provides dedicated, private connectivity between your data center and AWS for consistent performance and security. For the exam, remember this. Hybrid deployment equals on-premises plus AWS working together. It's best suited for organizations with existing data centers, strict compliance requirements, disaster recovery needs, or workloads that must remain local while still benefiting from AWS scalability and services. Say, or private cloud. Thank you for watching. See you in the next class.